This video, I want to talk about the topological problem for this one, and I first go the course schedule. This is a classical topological sort, and the topological has a two method. One is BFS, DF, another is DFS, but the BFS is easily to consider thinking the logical, and the DFS I will later to discuss the DFS. Today I will to use the BFS to solve the problem. The BFS basic idea is from this is a directed graph, and every graph has a prerequisite cost, and so for the BFS first start the node which has a zero integrate for every integrate node to visit it, and then this will remove the integrate node, and it will remove this edge, and then the next node will be minus the integrate, and if the next node integrate changes as 0, and I will push this node into Q, and until no any node no any node no any node exists, and finally I will to check that for the integrate. First one is 0, and I will to delete it, and the 1 will be the integrate will be changed 0, and I will continue to delete the 1, and the last one too, the integrate will be changed as 0, and then visit it, and also to after to pop all elements, and I will to check whether all numbers, all cost number, all costs will be visited. So I need to implement, and first I will to create a graph, directed graph. The graph I will use a adjacent table, graph table to experiment it. So for adjacent table, I will use a map, and for the key is every node, and the value is a connected kinetic node from this node. We'll get a map, and then I'm going to create this graph, and we'll EDG. This is a edge represents, and I need also a integrate array to express the integrate for every node. So the cost is if the array is first 0 and the second is 1, that means if I want to take 0, and I have to first take cost 1. So that means the second element is a prerequisite element for the first element, and I will do map computer add the next element. First element is this one from 1 to 0 in the 1 to 0 from 1 to 0, they will to get a new hash rate. And the integrate will be +1. Integrate is a EDG. Some elements connect to the element. This is directed DAC, directed ADG 0. For I will use the BFS. BFS is the first to define the queue. For every integrate 0, I will to add it, add into the numbers. Add into the I and the degree. If degree is 0, and then I will to go the main framework of this BFS. BFS basic framework is first to check is not empty, and I will pop up every element. You need to pop it, and for the next, I will to loop the next from this current node. Map get or default is a CR and a new, and then I will to get the from first integrate for next -1, because this current should be deleted. This edge from current to next will be removed. Right now will be removed, and then every -1, and I will continue check whether this current next integrate is 0. If this is 0, QE will be offer it, and offer it next. That will be finished, and if all the elements all element is visited, and I will use a count to check how many calls has been visited. When I pop any element from the queue, and I will let the count -1, and I will return the count equals 0. If it's 0, that means I visited all the calls. If not 0, and that means I don't. This graph cannot set the calls, all the calls schedule. And then we'll integrate. Will be integrate. Q is offer. Now, if it's now point, and if it's now, and I will get the now. If it's now, map is now, next will be next. Get or default is now. If we continue, map cannot contain this one. That means I need to continue. I will try more. This should, second should be return false. I will submit it. This is pass. So that means for the key point is to create a graph and use the integrate to record the current integrate value for every node. So then I will use the BFS basic framework, and for the for push element into the queue, condition is this node integrate is 0, and when every step goes BFS steps, and then pop the current node from the current node to visit the next node or the next node of this current node, and if the next node integrate change as 0, and continue add this next element into the queue until it's finished, and that is topological sort basic problem. And for the next videos, and I will continue to talk about the topological sorts. Thank you very much. Sorry, I will